Testing, testing. Okay, check, check. I believe we're ready to start. So I'm going to do this every day. Oh, I have to get rid of my double sound. Okay. So I'm just going to continue this series, which is a getting started series in learning Grasshopper for Rhino. You can see here I made a model, single node, pretty, well, how many we have? 50 lines, 57 lines of script, pretty easy script. I need to watch her. Oh, we have a girl that's on her way out the door, and then we'll have some quiet time. And it's parametric. It produces some interesting points that moves out into another structure. Oh, lots of people coming back in the house. And a nice little parametric model that if you watch the last video, it's about a half an hour. It did what it did with topological spaces, this one, and this is where I started adding a little bit of Grasshopper logic afterwards, which can be fairly fun. And you can figure out some pretty simple models. The best thing that I'm teaching is how to let GPT take your initial prompts and brainstorm some ideas from text. And I think this really is the way I will come at teaching this back in school in the fall, to avoid having to teach an entire CAD program, a parametric modeling system, node scripting, and getting into learning Python. It's the immediacy of this. So let's jump in and let's take a look. So topological surfaces, I love math type as image prompts, and I need to give a shout out to them because they're absolutely fantastic. And if you have everybody you want to contact and get watching this with us, I'll respond to the notes on my other screen. If anything's typed in, just say hi for the morning. I'm trying to do this summer and be consistent, but of course I'm only consistent if I have anybody interested in what I'm doing. Then I just change gears. I do have some wonderful projects going. All my GitHubs are available for free, except for the work that I'm developing in 2024, which is dealing with calculus, machine learning, and the Flash server with 3JS. And those are three things that are at wickersonstudios.com. And the rest of the stuff is all on GitHub at M. Wickerson. So let's take a look through here and let's just keep going and see if anything's of interest. And if you don't know what these visually are, if you haven't come across them in math or engineering or architecture, just skip over them. The uncertainty principle is pretty nice. It deals with variance, deals with momentum. I can't guarantee, but let's take a snipping shot of that, because I think it's amazing that GPT can jump into here and analyze this all for you in case you get stuck, and you're not stuck going back to the library, digging up all this stuff and reading textbooks on it. That seems to be an older way of education, which does work, and I spend a lot of time on that. But I like the immediacy of this. So in 30 minutes, let's try and make an uncertainty principle inspired model. So let's save that. Let's jump in here and call it the uncertainty principle, and we'll just get rid of that capture. And all this will be available after I get a dozen of these on here. Let's copy that and hit save. And then what we want to do is jump over here and we want to grab the prompt. But before we do that, I am going to take my older file. I'm going to save my older one. I'm going to save a new document as 9. And you can see up here the ones I've already done, which are available. I'm not saving a lot of these. I messed it up. Let's go back into Grasshopper. Well, let's just type it. Uncertainty principle. And that would be enough to get us started. And we can go back into math type and we can grab the, we can grab this prompt that works really, really well. And I will also send, when I'm done, for anybody with GPT 4.0, which should be everybody, I can share the link to all of this, of what I've done, which is a really fast way of learning how to text prompt. People doing this are just going to, they're going to fly at making models. But yes, there's a bit of uncertainty in it, and certainly having to be creative and having to have some life experience and knowing what you want. So double check your practice and what you're good at, why you went to school, or what you put into practice in your life, or how you played as a child. And let's copy this and let's put it in here as a prompt, text prompt. You can see it's create a Python script that works in the node editor in Grasshopper for Rhino 8. You can use the template of the C++, which is better for developers, but I think Python's incredible because you can get into the advanced Python libraries if you've got everything uploaded on in an environment in Python that allows you to use all those advanced libraries. And I'll get to that in time. Right now, we're dealing with Getting Started Part 2. And that's going to be a long series. Then we'll get more advanced if this goes well. So let's jump in here and grab the uncertainty principle. And that's enough to write us a script. And it's writing incredibly fast. And in preparation for that, we want to go in here and we want to update the first text that comes out, and we want to call this the uncertainty principle, and then we'll just wait to put the text that comes out, And then down here, we can scrap all this stuff, which was handy. So it's good to have some skills really with Grasshopper, more so than Rhino. Of course, you need Rhino to know Grasshopper. The uncertainty principle is here. I'm going to type it in one more time. The uncertainty, and I'm a little inconsistent with how I kind of list all this stuff, but in Pascal pace and Camel pace, but I'm sure it will slowly find its way. Principle, and this is the first version of it. We want to run that script without the past script in it, so we're going to delete that, and we're going to run it. And we have to remember that all this typesetting and inputs and outputs are irrelevant, but since GPT has a great memory, let's just leave it as that running empty and go back over to here, and you'll see the uncertainty principle has already given us a text for what it wants to do. So let's grab that and let's keep our files together. And I will just pop this in here. And the only thing I have to do, for those that have watched a couple times, I'm incredibly consistent on this stuff. So just if you do it once, I'll show you once, I'll tell you twice, and the third time you're on your own. And I actually think this is the new form of education. I'm a firm believer that anybody sitting here watching these tutorials does not need to be paying tuition, nor paying, I mean, you have to pay for some software and licenses and things like that, but you do not need to be in any particular place or time to enjoy this. I do like the live sessions, so just say hi. If you're there, you don't have to. But I don't really, unless I like the video, I don't keep it. So all of those other, all of these ones that I made videos to, I've erased after making them live. And that's the way it'll keep people coming back to see the live sessions. I did keep the topographical spaces going, but I like this one. So that's it. Now let's see if we can run a script. So you want a hard-coded script that's been generated, and here it is. And if it's taking its time, GPT-4o, and I'll do this exactly the same every day, like Bob Ross's painting classes. Let's hit reset. And let me know if you want to see my face. I'm not really a firm believer in looking at who I am. I don't mind the chats. I guess when I like music, I like bands that didn't plaster their image all over the cover like Cheap Trick and Kiss. I like the bands that had good music. Then again, Band of Gypsies by Jimi Hendrix was pretty good, and they did put their kind of filtered image on the cover. So there we go. We've written it. We have an A out and a B out. So we immediately can go to this other script and get rid of that. We don't know the types of geometries coming in, so we'll just want to see what they are in a panel tool to start. So we'll see what those things are. And then we'll put them into the right containers. I am getting a little more specific for my past videos to not use a generic geometry container. I kind of want to know when their curves, their points, and text-based objects and data and integers and floats. So I'll just leave that open, and you can see how fast this goes. I can grab that script. We can anticipate plugins are going to be 5 input parameters, num, points, position variance. I do it my way. You find your way that you're comfortable with. But let's pop this in here and see if we get any geometries. And this is where the real imagination takes over. You're looking at back-end Python programming with complex mathematics that are image prompted in Grasshopper. So write that down and tell your friends and interns and students that, and get people watching these videos. And I may consistently jump on here online. And let's hit run. And if we're successful, we have output some things. And here we go. We are outputting probably points here. And there they all are. And there's quite a bit of them. We can check with the param viewer. That's about all I like to do, 100 units. And then B, I'm not sure what it is, but it is curves. And how many do we have? We have curves with a param viewer, 20 curves. So what has happened in this script? Let's take a look visually. And there you go. And all you'll need in your command line are very simple, ZEA, and there you go. It's a similar pattern to what the last one made. The uncertainty principle has allowed us to have a parametric control of a point cloud that brings these lines somewhat together, disconnected. And let's see if we can parametrically adjust this. So let's go in and let's take number of points. And this is when you're working back in Grasshopper. Let's copy that. Let's paste it over here. Number of points is here. It's already on there, so we're fine. Point variance is a variable, is a float at 1. So I'm going to copy that, and I'm going to see if any names are the same. There's not, so I'm going to put that in here and call that point variance. Make sure there's no space after cutting and pasting these. If you grab things that are longer and you put a variable in with that little space there, it's going to look for that space and it's not going to link up and your node's going to go red. So you just have to watch your debugging for that. These variances are so small. I think this slider is actually 0 to 10. I'm going to do a variance of negative. I don't know if a negative number will work, but let's just start with a negative. I like to play off of a domain or a range that can be played into a domain. So let's plug that in here at a negative number, see if we have issues. But we'll test that later. We'll bring that over here to a positive number, which is what it wanted to be, a 1. And then we have to take that name point various, and in our script, we of course have to make that the output. You don't have to do it this way, but this is the way I like to do it because I can see what I'd have to change it back to hard-coded. Momentum variance is one the same, so we're going to put that in. Height is still a float, so we can, well, we don't have to type in it differently. We can just change the name to height variance, and we can have that same range of 1, which seems to be the number. Always go close to the defaults. Then we have a seed, which is 42, so we can just leave that seed, and we have a number of sets, and we can just change that. It doesn't matter the order. Not in every case, but in this case it does. There is our number of curves, and we want our number of curves to be here, and we want our seed, which is already in our script, inputs, copy from the last one. We're just going to put that in seed. We do not need the set radius, and we've got a seed that goes in, and we do not need that number slider, and we should have something that is fully parametric now. So changing the points count is going to change what happens in our model, which is kind of nice. The position variance is going to invert it. So those are like vectors moving in different directions. You can think of this more computationally and simply. I try and take all my models initially from points and curves and lines and build geometry from that, because I think the inspiration comes from seeing a constellation. And you can see that I have a momentum variance. And keep in mind, we're dealing with the uncertainty principle, which may be just the logic that's enough to build a cool algorithm to build an interesting model. There's no guarantee of that. And then we've got our seed value, which I'm pretty sure, and I'll say it every time whenever I see it, 42 is the answer to the universe, I think. So why not put your seed value at 42? We have 1, 2, 3, we have 9 distinct curves that are coming together. And we have a number of curves which we can change that's more specific. So let's just choose 6 curves. Look at that constellation. And unless you kind of make it absurd, like with that point cloud, and if we took those numbers of curves up very high, I'm going to, because this one can handle it, I'm going to pump that up to 100. And I'm going to set that curves to 60. We start to see this interesting kind of geometric form. I'm not really seeing anything magic about this. So with that logic running, this is your time to think and brainstorm. And we can take this and we can just stall out for a little bit, take this uncertainty principle, and sometimes we just have to add some other type of logic to it. And you can be fairly absurd in the conversations that you want to have. I'm going to turn that preview off. We have our points, and we have here. I'm just going to do something geometric to demonstrate. Like, you could do it in Grasshopper, like with these points, which are, well, it's just one big list of 25 items. That's not really going to help. They're not organized into a tree structure. Lists are not as interesting as trees. I'm not sure where I'm going to go with this. So we'll give it one more try on GPT and say, great, this is working. But can you modify the script so that a more interesting geometry, let's say that more interesting geometries create a more complex model. Be sure to create midpoints of lines, offset those points, and create 3-point arches, arcs or arches from the midpoint and their respective endpoints. And I'm just thinking what I want to do computationally in Grasshopper, but I'm asking it to figure it out within the script itself, so I can save myself the overhead of going in here, finding these lines, separating them all. It's not that hard for those that know Grasshopper, finding your midpoint to these lines, and then each one of those lines. Basically, I'm asking the script to find those endpoints to those lines, and then from these 3 points, I could build an arc, curve, analysis, primitives, 3-point arc. Basically, I'm doing this, which is just good practice. Take your A point in the middle, take your end point, take your this point, and you should be able to, what happened? Points are, well, those midpoints of 25 items, these curves are 60 curves. So that's tricky. That's not going to work because you can see the problem that some of the curves are linear curves. There's 60 curves. I should get 60 points, and I did an offset. So you need to extrude or move, and at that point, the move has got to move in a direction. So if I moved it in a x-axis and used a default on that, this point could be the center point. So you're thinking geometrically what I want to do, and there you go. You start to pull those arches off in that direction, which could make for a pretty simple, interesting model. So we'll just grab 2.0. That's probably pretty heavy. Yeah, because my model is very small. So let's just grab a 2.00 and just have a little bit of power to pull those arches off in a direction. And you see you're starting to play with this model. Normally what you would write, but let's not do that. I mean, I still am brainstorming as to what kind of model this might want to be. But since that one works, you just work iteratively. You take it down here, you copy it. It's very fast scripts because it's dealing in points and lines. Let's put it to a third iteration. Let's take this one and just preview off. Now we're down to this one, and we're waiting for an upgrade on this script. And sometimes I just like to clear the script so there's no typos. We have new variables. This is writing, and it's writing slow. It does write really slow when you leave it behind the scenes. So once again, GPT-4o, you want to hit refresh, and that if it's already written it into its memory, it will just output it on that screen. And I'll say it again, I think GPT-4o is actually keeping track of me and the pace at which I do prompts, and it's pacing itself. And you can see here the outputs you can start to pull, the ABC outs, the arch outs, just the curves out and the points out. You can also have inputs that are coming a little more. We've got our 1, 2, 3, 4, 5, and we only have to set a distance variant, which makes sense. Copy that, and we will want to go in here and add one more variable as a float. So pretty simple scripting techniques, and we'll make the offset variance, well, very, very small like we did 2.00. So that script is a way of getting around modeling in Grasshopper or in Rhino iteratively. You're just telling the script what you want to do. And instead of trying to find the solutions between OCD, I say OCD whenever I'm straightening things up. And if I was like Lewis Garcia, like parametric camp, I'd straighten this one out and I'd make that one snap in place with maybe the plugin Gecko. I'm not one to use plugins. I know it seems to be a few here, but I really don't get into them anymore. I play with a few basic, I stay within math sets and vectors, and I do 90% of my work within those. And I'm very happy with containers, and very few even display items. If I want to do display, I'll take this whole script over to Flash server and use 3JS. So let's see what happened. It's not too exciting because there's nothing there. Let's see what it wrote for us. There's our script. We do have to change a few things. Copy. We have some more outs. And we're going to put down C out. And we're going to take that geometry and we're going to find out what that one can be. I think it tells us in the script what it was. Arches out, so they're going to be curves. So that's easy. and we're going to get arches, and hopefully we get a really nice definition of one. And did I copy my script yet? Copy, and put it in here. So that's it. And I'm not sure the direction of where it chose. It might have done tangents or who knows, but we have a bunch of planar curves, and let's see which direction they look. So they're all over the map. Those curves actually did much more beautifully in line with where the direction of those lines was going. And I think that's a much more beautiful script than you extruding out in a direction. Now, nothing's working here because I have to take my offsets are 0.5. That's a very small offset. So I'm going to even bring this down, edit, and bring this down to maybe 2 instead of 10 and reset it. And then I'm going to just copy over points to 100. I do this because what I could do is I could put it in and then go ahead and then hashtag the hard code. And that's a technique to do it. But since this isn't a very complex script, I will just override the 1 on everything, the momentum variance, and I will offset. And you're breaking a little bit of Python rules if you're getting beyond a certain amount of characters, but I can live with that because how many people are going to dig into my script? The best thing is this entire class does not have to be uploading videos. This entire system of what's happening here, it is running, is fully accessible to anyone by this link. Failed to clipboard the link, could not create a link. Am I not on what I'm thinking about is I think no, I'm on GPT 4.0. I should be able to make a link unless it gets so big and ugly. It's got image prompts. I should be able to make a link, and then you can track all of this data by one browser link, and you can see all of my forms. And giving this to someone, this is literally the course. You would have students that would submit, I believe in the future, and mark my words and write it down, people will submit to teachers and researchers this transcript. So I can see evidence of how you were thinking logically. I can see how intelligent you were, how you solved problems, how you iterated through scripts, how you used debugging tools. That really would be evidence that I would say to a class, you've got a 1,000-line transcript to hand in by Monday. And what a boring teacher I would be doing something like that. But I'm rethinking what school is, how I teach, and how I have outcomes. And I'm also in an art school, so I really am just looking for creative solutions. And you can really kind of get lucrative. And from a critique scenario, you could go in, and what I really like about GPT-4 is anytime you've prompted it, we can then go on and edit and rechange. It's almost like an update on a Jupyter notebook. So think about that. Man, I'm coming up with some pretty cool analogies to what this is. So I think we've done it. If we grab our script and we take a look at it, we take our point count down, we simply position the variance here, and now I have my analogy of what I want. These look like, as I change these are just the seed. Once again, I always like to, sometimes my seed, I just like to edit snapping. Don't ask me why, it's just like, maybe it's OCD as well. 42, I like to snap to 42 because I like 42. I feel that answer to the universe might be in that. And then I've got my number of curves down to here. Now take a look at this. What do you see in this as you go? And those scripts are bowing, but now my model's gotten much bigger. Or I meant to take this to 2.0, not 0.2. So I meant to have something that was more scalable out like this. There you go. So this is kind of an insane basis of an artwork that is computationally driven by 66 lines of script. But I'm starting to see something. And I think as a creative, you've got to allow your mind to wander. So I'm going to go up here. I'm going to take this geometry and hit preview off. And what are we working on? 29 minutes. 2 people watching. Thanks for being there. I may leave this one up. I may not. I think I'm answering things consistently and repetitively that you could possibly learn from this. But if it's not your bag, don't worry about it. It won't offend me. I've never really learned to profit off of this outside of just practicing and enjoying it. And if I was doing crosswords or Sudoku, I doubt you'd be watching that, but that's somewhat enjoyable too. So what we're going to do to this uncertainty principle number 4, we're going to look at the model. We can get rid of it because I'm not going to need it anymore. And now I'm going to say, wow, this is cool. Is it possible to create some surfaces that resemble billowing sails of a ship in a modified model? Maybe sails doesn't have to be capitalized. I might throw it off. What is a sail? Capital sails of a ship. Billowing canvas. That might confuse it. Canvas sails of a ship in a modified script and algorithm and model. If so, it is okay if the sails blow in different directions. I think this would be cool. And, I'm just talking kind of, wait, let's stop that. I wasn't done. Let's edit. Let's get that sails of a ship. That's what the problem was. Sails of a ship. And let's give it a wow and let's send it. So now we are thinking about what that model was. It's going to start processing. I just modeled enough creatively, and that's what I would encourage anybody to do. And this is kind of like what I call it lucid dreaming with OpenAI. You're awake. You're controlling what the world is bringing you. You're living in the moment. You're living in this wonderful eternal now. You're not too worried about the future. What harm am I doing to the planet sitting here outside of using a little bit of energy, minding my business and sharing what I'm doing? To me, this is very similar to just playing music, picking up a banjo and plucking away at it and having fun with it. I like these little models. I mean, obviously it's not connected to any ship hull or anything like that, and there's beautiful, but these are like little tiny functions that do some cool stuff. It would take a lot more intelligence on my part to break it down and try and hook up nodes. It would have a huge fast overhead, but all this is running in under 100 milliseconds, and I'm pretty happy with that. I think I have my profiler on, so if I take this up, maybe the profile, yeah, it's 7 milliseconds. 6 milliseconds. This is not a heavy script. And if you want to then pull your stuff out and go slower and build these can of worm objects with Grasshopper and you're used to doing that, go right ahead if your boss is impressed by that or your teacher likes that. But I really am not. I want the simplest, fastest thing that does the most. And well, that's totally a lie if you know anything about me, but that's okay. I don't have to be consistent. And let's take a look back. We're not going to use this model. If you come to my scripts, you probably just look at them in the gray. Obviously, all of this kind of irritates me. All of this excites me. We'll put that in the middle. All of these would be nicely organized in the middle. And all of these guys would be lovely organized to the right. There you go. And you've got a nice, better looking script. And even that bothers me. So here we are. Nice little scripts. I used to plan a whole class that people could learn Rhino, learn Grasshopper one week, learn a little bit of Python in another. But GPT is changing this world. So there it is. It's writing it. It's taking its time. Let's do a refresh. And once again, I'll say it again for consistency. That GPT, I think, is analyzing the speed at which I'm making scripts. And I have made tons and tons of scripts. They're not hard to do. And GPT is probably the best teacher I've ever had in my entire life. Sorry to say that, but if I have a question, I don't have to look around for somebody to ask, and I certainly can get the answer. That will be one of the best answers. Not the most creative answer, but leave that within your own mind. Here we are, points out, blah, 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 sales out. Ooh, generated sales surfaces. And look at those added variables. 1, 2, 3, 4, 5, 6, 7. And now we have number of sales. Those were number of curves. Now we have number of sales and 3 other items. I just have to go back and forth. Number of sales is going to go here. And we shouldn't really get ahead of ourselves. We should take this hard-coded script. Don't make the mistake of hooking everything out. It's a waste of time. Put it in here, uncertainty principle, and let's run it. And we're outputting, so let's see what we have. We definitely need one more thing to see it. D sales out, and this could be a total abstraction and nothing reasonable to the world, but it's trying to get better. Let's grab D out and put it in here. And we also want a param container that's going to be surfaces, but at that point, when it gets heavy, then the geometry gets heavy, I just put it in a geometry node, and we have created nothing. Maybe I have to reset it. There it is. Yeah, I have to run the script again. So there you go. You've got 4 sales. Where are they? There they are. How beautiful. It's not super fancy, but it's a model that creatively and iteratively is going through developing the thoughts in my mind. And at this point, I will go down and I will probably, to save time, go up to this script and grab all of this juice. Inputs, copy all the way down to offset distances. And then offset distances, I'll probably put that in here because I don't want to have to retype it all. Now I did get rid of number sales. We're going to add that to over here. The number of sales will be an integer. Number of sales, integer value. And we will also put it in instead of 5, we'll put it in there. And just to remember, you might want to make your sliders relative to the numbers. Just think of parameters and numbers like that, floats and numbers and booleans, or to scale it, floats and numbers, integers. Sale width is a float. So we can go in here and we can just give that a value, and we want to set that to a float. Typesetting and assignment and declaration, and we can take that and replace that. And then we have the sale height, copy that, put it in here, and run it down here. And we'll have to also typeset that. Don't worry about list access right now. We're staying pretty simple. I didn't want integers. I wanted doubles or floats, depending on the program you're dealing with. Let's go to 12.00. Heights and widths could be interesting. And let's see what parametric modeling we can do. And I just think this is like a cluster that everybody ever wanted. You can definitely name these sliders if you want. OCD. And let's take a look at what we have. So we have this project that will generate points. And you can think of these points now as related to these surfaces. So you've got the geometries that you could start to further model this. So these points connected with lines or capillary catenary arches, you could have a gravity of these arches go to these surfaces, and these surfaces could be brep edges. No, we could deconstruct brep. Pretty simple stuff that you're probably used to, maybe. Deconstruct brep. So if I pull that out, I could build a catenary arch or another 3-point arch, but to make things simple now, because I don't want to get busy and distracted, let's grab those initial points, all of them, and connect them off to the points. And obviously, you may not want this because that's too many, but you could call out ones, but you're getting this sense of a model that then interconnects with the other ones. But that's taking your geometry up more than what this is, which is points, curves, the billows, and then the sales being informed by the billows. And I'm not really sure how the logic is happening. It's not really billowing in a way I wanted, but let's take 20 of these objects. We definitely have to make some finesse. But if you're into abstract sculpture and sheet and points and lines and engineering and architecture, let's leave our seed where it's at. We're just putting on more and more curves. I'm not sure what the relationship between the curves and the sails will be. They seem fairly distinct. So these surfaces are really built from a point system and stretching out. And I don't know if they're really related to where it was. But if you don't know what your model looks like, once again, the command line ZEA, you kind of get a sense of what you made. It's just an abstract model. I was thinking a little bit. I'm not going to overthink it. As a model to the uncertainty principle inspiring a few of these projects. I am wondering if I changed it ZA. There you go. It's not anything fancy. So if you stuck around here for 45 minutes and you're not impressed with the model, that's fine. It's not really that important. What's kind of important is that you realize how you can simplify your Grasshopper world, you can work creatively, and you can learn an awful lot about GPT, and you can inspire what you want. So as we kind of end, not to be too depressed, I did make a great model from that one. I think my last one on topological surfaces is pretty amazing. When I look back at these, I didn't do all of these. Orbit was okay, but you'll just have to look at the scripts to see what you wanted. But let's see if we could just fly through here and set up for another one. Uncertainty principle. Matrices imply the summation. That looks complex enough. And if you don't fully understand it, the wave function, particle at rest, and mass, it could be interesting. So just get ready for another script. We'll keep going on this 2.0 getting started. And I think 42 minutes is enough this morning. I might leave this video up because the outcome was not magical. I probably will delete it, but thanks for watching and being there. I'll be back on tonight, probably 6 o'clock or something like that. And the 6 o'clock evening sessions are a little quieter. I usually hit mute on my mic and I just go until I see comments. But that's how I